Welcome everybody. I'm Mark Fox, CEO of NetEvents, and delighted to welcome all the press from around the world for today's session on open networking, agility and control for a new era of connectivity. We're delighted to introduce our partner for today's event, which is Brad Casemore of IDC, who will be chairing the Sustain panel. So Brad, over to you.
Thanks very much, Mark. It's my pleasure to be here, and we have an excellent panel for you today and also a great topic. We're going to talk about open networking. We're going to tell you, we're going to explore the definition of the term, we're going to help define it, and then we're going to talk about what it can offer enterprises and other organizations in a wide range of areas that confer benefits, from agility and control through to OpEx and CapEx savings, greater efficiencies, better alignment with application pipelines, and so forth. We have a great panel today. I will mention them briefly. They'll have an opportunity shortly to introduce themselves. We have Ihab Tarazi, who's the SVP and CTO of Integrated Products and Solutions at Dell Technologies. We have Dave Maltz, who is a Technical Fellow and Corporate Vice President at Microsoft. We have Rebecca Weekly, who's the Chair and President of the Board of the Open Compute Project, otherwise known as OCP. And we have Pere Monclus, who's the VP and CTO of networking at VMware. So great panel. It's going to be a very lively discussion. We can talk to you about what I'm going to present. I'm basically going to queue it up. I'm going to provide some context for our panelists and for the discussion that will ensue subsequently. So one of the things that's interesting about open networking is just the battle over exactly what it means. And we will be tackling that head on today. We know what it should do. It should provide openness, it should provide flexibility, it should provide choice through disaggregation of the various components and layers of the network throughout the network stack. And it really has the promise on the benefit side to reduce cost and provide greater efficiencies. Vendors have, in some cases, slightly definition of what that entails. Does it mean having an open API? Does it mean having openness from one part of the network to the other? Does it mean network disaggregation? Does it entail the use of open source software and open source hardware? And the challenge for the industry, and certainly for enterprise customers and the folks who you're providing reporting for, is to figure out exactly what it means and to eliminate or at least mitigate any ambiguity and potential confusion. We know ambiguity is great when you're reading a novel. It makes the characters more interesting and the plot more captivating, but it's not so good in a commercial context where you have to clearly understand what it is we're discussing and what it means. Here we can talk about the role of open source software. There's also open source hardware, and you're going to learn more about that today. But from a software perspective, how is it contributing to changes in the role and purpose of the network and what networking means in the context of modernized digital infrastructure? All enterprises today are striving to provide modern digital infrastructure that is more cloud-like in its architecture or more cloud-like in its operational model. That involves the use of open source APIs, a greater degree of automation throughout the life cycle, use of more virtualized and containerized as we move forward network functions, and how you service chain those and insert them into basically an inline model. We're seeing more use cases that involve open networking and open source, and we're moving to more software-driven processes that are more aligned to how developers work and more aligned to the needs of the application. And the interesting thing that we're seeing at IDC is not only is this changing what networking does, but it's also beginning to change who does networking and basically who operates the network. So architects and platform teams are a great example now at the higher end of the stack in terms of getting involved with the network. And they're using connectivity and networking in ways that are intimately tied to the application. And what they want from the network is different from the nature of traditional network products and the way they're not only purchased, but the way they are deployed and the way they're managed. And that brings us to the next stage of the discussion, which is the growing popularity of open source and open networking projects. We see, and you're going to hear more about the Sonic network operating system, which is an open source network operating system that was created at Microsoft, and we have Dave here to talk a little bit about how that evolved and where it's going. We see that market, the forecast for Sonic-based Ethernet data center switches will be worth approximately 2.5 billion in 2025. This is quite something when you consider that a few years ago there were no Sonic switches on the market. And the interesting thing there is these aren't just going to hyperscalers, as you're going to hear later. These are making their way into a broader range of customers. Yes, they're still in hyperscale, but they're also moving to tier 2 and 3 clouds. They're moving out to large enterprises in verticals such as financial services. So there really is tremendous growth occurring there. Then there are things like service mesh, higher up the stack, up at the application layer. Many of those, in fact, almost all of those are powered by open source projects at their core, and that will generate more than 800 million in revenue in 2025. There are some exciting other open source projects such as eBPF and Cilium, considerable market potential for networking, for observability and visibility, and also for network security use cases. And there's a growing community and ecosystem there, and a lot of VC money going into that area too. Open source networking projects, hardware and software, continue to proliferate up and down the stack from, you could arguably say layer 1 all the way up to layer 7. And they're spanning an increasing number of use cases and addressable markets. We're seeing, of course, a lot of activity in telco. We will be focusing too much on that today, but certainly we're seeing a lot of that in telco cloud, in 5G MEC, the edge. We're seeing open networking really take hold through all places in the network and through all layers of the network. And that brings us to where we see all of this going in the next slide. We're going to talk about assessing the benefits and weighing the risk as this phenomenon progresses and is embraced by more enterprises. What we're seeing is that they're beginning to clearly understand the benefits. They're beginning to understand that they can derive agility, they can gain business and digital resilience. There are operational efficiencies that come from being able to leverage an open network, one that gives you choices at each layer of the stack, one that can be extensively automated. And they're also seeing that as a result of that, you're able to better align with application needs and CI/CD pipelines of developers and DevOps. And there's tremendous value there because the network then goes from being this specialized silo, which was operated off on its own to the side, to being really part of how you serve applications, customers, and employees. The network becomes a critical digital conduit for all of that. And at the end of the day, if you're looking at, improving your security postures, that's another area where this plays a big role because you're able to put together a more secure environment through your network, through having that choice and through being able to automate it and automate throughout the life cycle. And you can also derive lower CapEx and OpEx because, again, you have that choice. But there are risks. And one of the things that we will delve into today is how you can mitigate those, how you can get the best of open networking and avoid some of the pitfalls. And the pitfalls can derive from the lack of internal expertise and skills within your organization. In other words, you have a group of people who aren't yet used to this model and aren't yet used to harnessing this technology. Sometimes you have a poor understanding of the implications of what it means to go in this direction and what you need to do from a requirement standpoint. And occasionally there's also a limited capacity to provide support and service for some of these environments. And we'll talk about, how you can ensure that you can move in this direction and get what you need for your heterogeneous network and for your use of, in some cases, open source as part of that model. And now we'll move to the next slide where we talk about the future. And I'm sure we'll have many opinions on where this is going. The rise of cloud native application architectures, for instance, is presenting more opportunities for open networking. And there's a growing need for multi-cluster and multi-cloud networking. And that appears destined to further propagate and extend the reach of open networking and open source networking. And as a result, enterprises and their suppliers, the vendors out there, need to be able to adapt to that shift and provide solutions for the customers so that they can move forward. So without any further ado, we'll move into formal introductions of our panelists today. I'm going to give each of them a chance to introduce themselves, and then we'll delve right into the first set of questions. First up, we have Ihab Tarazi. Ihab, please introduce yourself.
Yep, thank you very much, Brad. I'm really excited to be on this panel. I'm really passionate about this topic, so thank you. You summarized it awesome here. I'm the SVP and CTO of Integrated Products and Solutions at Dell, responsible for many of our platforms from a CTO perspective, including networking, edge, 5G, AI, HPC, and lots of our server platforms. So I have been working in networking my whole life, being VP of Engineering at Verizon initially. And then I was CTO at Equinix, where we built one of the first large-scale open networking platforms, Cloud Exchange. And now I'm at Dell for the last 3 years. Thank you.
Excellent, thank you. And we also have with us today, Dave Maltz. Dave, tell the audience a bit about yourself. Yeah.
Sure, Brad, thanks for having me on this panel. Really happy to be here and talk about open networking. I wear two hats. I'm here partly as my role as one of the founders of Sonic, Software for Open Networking in the Cloud. It's a project we started at Microsoft, but as you'll hear, has grown much larger than that, driving disaggregated software for the networking space and all the cool features and capabilities and innovation that unlocks, as well as what it gives us in terms of the higher availability and better quality networking. My day job is as the engineering leader for Azure networking. I'm responsible for all the networking in Azure, from our physical networks inside of our data centers, our wide area network, all of the management services that run our network, as well as then network related services like DNS, traffic managers, our edge services as well. And so happy to be here and share those perspectives. Thanks
very much, Dave. And we have Rebecca Weekly from OCP, and of course, Dave will know all about OCP from Sonic's involvement there. Rebecca, it's great to welcome you today. I wonder if you could provide an introduction.
Sure. My name is Rebecca Weekly, and I am the president and chair of the Open Compute Project. My day job, to quote Dave there, is I actually work for Intel. I'm VP and GM of the hyperscale business there. And, really for me, this is an exciting opportunity because as OCP thinks about open compute in general, network has been probably the domain where we've had the most interesting transitions in the last 10 years. So it's been a community that has served operators, certainly in that definition of network, and maybe we'll get into it a little bit, but there's many, many different ways in which we think about networking within the domain space of computation. And so we've done a lot in partnership with Sonic and Psy specifically, certainly, and a lot in the domain space of distributed systems, all the way through to obviously the software layers. There's just great work that is happening in this community that has been led by so many fantastic hyperscale innovations, but also really different communities coming together to serve different needs as the market has evolved.
Excellent, thank you very much. And now we have Pere Monclus, who's from VMware. Pere, it's great to welcome you. I know you've been on other panels with me and with the team at NetEvents, but feel free to introduce yourself.
Yeah, thanks, Brad, for having me here in this panel. Super exciting to talk about open networking. So I'm the VP and CTO in the Network and Security Business Unit here at VMware. And as everybody, wearing multiple hats from driving innovation and strategy in this new and dynamic field of networking as we go across clouds, across application environments and so on, and how openness and changing the paradigm in terms of who controls it is super relevant. I came to VMware through the acquisition of a company that I started called PlanGrid. That company was the one that introduced eBPF in the industry, upstreaming that component in the Linux kernel. And before that, I was a distinguished engineer at Cisco for many years doing solutions around Datacenter, firewalls, and load balancers.
Excellent, excellent. Well, thank you very much to all the panelists for those introductions. And now we'll move on to our first set of questions as part of today's discussion. So I mentioned in my slide earlier, the topic of defining open networking. And I'd love to open it up to the panelists now about how you define open networking. And Ihab, let's start with you. How do you define open networking from wearing your hat at Dell?
Yep, excellent. So we have been pushing open networking as our strategy for the last 5 years or more. And that's really a key critical piece of our overall infrastructure, especially for data centers. For us, open networking has a couple of key aspects. The first one is being able to abstract the protocols away from the operating system, which is how do you provision, how do you activate the ports, how do you use open standards to be able to configure your network, configure your switch without being dependent on a proprietary operating system to manage the actual, network device. The second component of it is the ability to deploy protocols as needed and mix and match. So the ability to have a containerized cloud native architecture that allows you to add more containers on top so you can expand the number of protocols is critical. And then the third one, being able to customize it. How do you take fork it, be able to add to it, customize it? I think as Dave Maltz talked before about him being a founder of Sonic, we are a huge contributor there. We have been working with Microsoft almost from the beginning of the journey. And as we will talk about later, you'll see Sonic is uniquely positioned to be able to support all these different aspects of what is open networking.
Excellent, thank you. And Dave, that's a nice segue to you. I wonder if you could either, I think that you're basically in agreement with what Ihab just said, but feel free to discuss the topic from your perspective.
Absolutely, I'm very much in agreement with what Ihab said. And again, kudos to Dell for joining into this initiative very early. It has spread broadly now and has become something across the industry. To me, open networking involves a couple of things. One, it is open source. Open source is very important in that it enables full visibility into what's going on at all the different layers of the component. That's not to say that all aspects of networking need to be open source. Even in the Sonic ecosystem, portions of it remain closed source. There's proprietary IP, for example, from switch ASIC vendors, which they may want to hide behind the side, the switch abstraction interface APIs. So open source is an important component, although there may be some closed source. Disaggregation is key. I think that speaks to some of the things that Ihab was talking about, is the ability to bring different software to a particular hardware platform, to be able to choose which of the various protocols that you want to run, so that as a network architect or as a systems architect, you can assemble a solution out of just the pieces you need, not expose yourself to software that you're not using, which could introduce unwanted bugs or security vulnerabilities to your system. Another really important component that we're seeing a lot is decoupling and APIs, public APIs being introduced at critical portions of the network stack that then enable innovation above and below them. The switch abstraction interface, SI, that was published at OCP, critical part of that. We're seeing it in other layers now, like Dash, distributed APIs for Sonic hosts, where now we're creating APIs that'll let us open up parts of the SDN data plane. So again, there can be innovation below and innovation in the control planes above that. And then the third aspect of open networking is really around control. And that is allowing the end users to have more control over what's going on underneath them. Like we talked about, what software and protocols they use, what vendors they're working with, where they get different components of that solution from. So those are sort of the three key parts that I see in open networking.
Excellent. And that's a great transition over to Rebecca from the OCP perspective, where of course they've been involved in opening up compute and network hardware. So Rebecca, we'd love your perspective here.
Sure. We really started this effort in the domain space of open networking back in the end of 2013, if I'm remembering correctly. And it really was under these three common tenets. One is that concept of disaggregation. So you certainly referred to it earlier, Brad, but traditionally networking was very appliance-based. And that was really just a box with software on top that made everyone, have to integrate and align with that particular set of vendor APIs. So it was really trying to separate the network hardware from the network software so that there was an opportunity to integrate and work across different solution spaces. The other core two tenets are fully open. And Dave really referred to it very well. But by being able to sort of disaggregate at the hardware level, we were able to look at devices which were closed, maybe at the ASIC itself, but had common APIs that we could leverage across different switch vendors, across different, network and even networking cards, to be able to work across, to be able to allow automation or different, SDKs that would enable us to work together within the switch hardware all the way through to those networking ASICs. And then finally, rapid innovation, right? But the third core tenet of what makes open networking possible is that by standardizing some aspects of the overall stack, you can therefore allow people to get more innovative at the programming level for every aspect of how you do SDN. And I think that that is really where best of breed software can come together and have different deployment use cases all the way through to better security models, better, name your favorite flavor. So I think it really has been under disaggregation, fully open and rapid innovation models that enable us to approach open networking with, the best innovation from individual vendors and the entire community sourcing.
Excellent. Thank you very much, Rebecca. And now it's over to Pere. Pere, for your perspective, of course, VMware being a software company, I'm sure you'll have a very interesting take on this topic.
Yeah, maybe I'll take something that you said at the introduction, like who does networking, right? And maybe by that, networking has always had the need to be open. I mean, if you think when we were thinking that networking is done by operators, now you'd have company A managing a network, company B managing a network. But the premise about networking is that things have to communicate end to end. So by that fact, companies, I don't know, like a networking company A and networking company B, they had to interoperate because otherwise you would not have networking. So if you think the meaning of networking and open networking has changed over the years, like if you remember the standard bodies, IETF, IEEE, that was a way to open up the definition of protocols and packet formats because networking had to interoperate. Now, fast forward 20 years, the meaning of openness has changed, as Dave, Ihab, and Rebecca were mentioning, like opening from an open source point of view, operating systems, abstraction interfaces of size, and so on. That has contributed to create a much more open ecosystem, from open standards to open ecosystems, right? But now, if you take it to the next level, like who does networking? If you think application life cycle is what's driving the industry, right? In the sense that, or user management, but let's say you want to put an application in production in a multi-cloud world. Like now you need open interfaces. And this is where you get to this from API abstractions, like from Sonic to service meshes to Ciliums and eBPFs that you were mentioning. And this is where progressively the meaning of openness in networking is evolving as the needs of networking are evolving too. And this is how the industry is like very dynamic right now, because we are seeing an explosion of automation, management, agility, and so on that networking needs to follow. And that's why openness percolates across all the layers of the stack.
Yeah, absolutely. And that's a nice transition, Pere, to the second question in this segment. And you've already addressed it to a large extent. And we'll go over now to Dave. Dave, as a result of this opening up, right, and open source and open networking, we've seen an evolution in what networking is. I wonder if you could talk about some of that evolution, as obviously it's been already applied to what you're doing in the data center at Microsoft, but how do you see this broadening to the wider world in terms of the evolution of the purpose of networking and how it should provide value to enterprises?
Great question. So our world is becoming ever more distributed. A lot of the services we're building are distributed services that are being made available to their customers over networks. That places networking in a critical role, both for service availability, as well as things like functionality and security. And so one of the important areas that open networking is going now is making the network more of an active participant in, for example, securing the services that are being hosted on there. We see that happening at the virtualization layer, where there may be a shared physical infrastructure, which is now being virtualized and made specific to the policies of each of the tenants and services hosting on that. That's exactly what's happening in our cloud hosting facilities, But in the enterprise space, we see more and more the need to put security boundaries inside even their on-prem facilities or wherever they're offering their services from, so that they can make sure they have good defense in depth. Open networking, exposing these APIs, things like Sonic, which make it easy to then write additional management containers, which are going to run on each network switch, make it possible to have the actual network devices participate in the creation of those many layers of defense. By open networking, by opening up these what had been closed ecosystems to bring in more software from more vendors, from even the owners of the service themselves, enables tying those network devices into their control and management planes, so that the network as a whole isn't just a separate thing that forwards packets, but is actually a unified part of the auditing solution, the telemetry solution, using the fact that packets flow through the network devices to then provide information to the service operators and the service architects, so they can make sure that all the traffic flows in their network really are ones that they expect to be there, that they can dynamically tie whatever access control lists, packet logging, packet blocks into their control and management plane, so that when a service is first deployed to services connected by those network devices, along with the deployment of the code comes all the right kind of barriers to create and control the attack surface of that service and keep it safe. So these are ways that going forward in the future, open networking is going to enable service architects to have much better visibility, much deeper integration of the layers of their network.
Absolutely. And Dave, you said there's several security benefits to this, right? In terms of it really can fit with more of a zero trust model, right? In the way you build these things out. So that's a great point. Yeah.
Because the open networking enables that communication at the protocol layer between the services and the clients, and the services and each other.
Absolutely. Thank you very much. And Rebecca, I know from your perspective, you said earlier that, obviously there has been a big focus in the early stages of OCP and compute and network on serving hyperscalers, but you're seeing a real broadening of how this technology is being used, aren't you, right now?
Absolutely. Absolutely. So if you think about, the domain spaces that we are participating in within the networking project group at OCP, it's everything from obviously network switches and core and access, but also routers, gateways, all the way up to 800 gig, like novel switch and optical transceiver designs, everything you can imagine, even domain spaces. And I think Dave alluded to it beautifully, the concept of distributed computing requiring more and innovative solutions in your networking stack. So accurate timekeeping is another project that is really happening within the domain space to help drive efficiencies when you're trying to coordinate across thousands of servers. So there's so much that being able to, again, disaggregate and innovate across the software layers to be able to manage distributed compute, whether it's in a core data center, whether it's out to the edge, as we become more heterogeneous and disaggregated, just as a computational fabric in the world. So I think that has been probably the most interesting aspect of how it has evolved over the last 8+ years that we've had this kind of networking division. And we'll continue to see it, as we see this world of software continuing to become more diverse, more specialized in different workloads, whether it's AI, whether it's media transcoding at scale and distributed. We are continuing to see different kinds of compute, which are requiring different kinds of network shaping. So not just the security aspects that all of us were referring to that are incredibly painful to manage, but as we think about just the diversity of workloads that are happening and the complexity of them, we're seeing that there's different ways in which people want to actually shape network traffic to actually ensure that they don't have congestion in critical scenarios and have all of that be handled through disaggregated computing, because users are everywhere and that model can be everywhere. So I think that has been a huge area in which we've also seen, again, systems level innovation where everything has to come together. And maybe the last area I would look at and say that we've been able to make some progress, and certainly we look to the community to help us drive even more progress, is in the domain space of really sustainable solutions in networking, right? There's a huge amount of projects that are happening within OCP right now that are around reducing data center consumption of non-renewable resources, And that is huge and a wonderful opportunity, I would say, to think past just, hey, the latest and greatest hardware is what you need to have, and that creates a ton of waste within our economy. How can we create open interfaces where we can extend the life of hardware and ensure that we have embodied carbon being leveraged over longer lifespans? How can we use open software to continue to enable us to do that more and more? So there's huge amounts in terms of circular economy, but also in being able to extend how we are looking at the operation of efficiency through better network shaping, being able to use different kinds of hardware that actually operates together. So that's all the great stuff. In terms of the risks, we certainly see within a broad community of 282 different kinds of companies, from operators, enterprises in the retail space, financial services, as well as hyperscalers, that there's going to continue to be complexity in managing open hardware if there aren't solutions providers and new innovative solutions providers on top that will help support others. So we have seen that, for years. If I'll take just a simple analogy of Red Hat with Linux, this is certainly an area where we are going to need to see different vendors step up to support all kinds of users within the community. So we can have open hardware and still have interesting solutions for services to help end users consume. So we always try and source from our community together to make sure that there's a path to a product that any kind of user can consume, and ensure that there's every kind of business model innovation on top of it to ensure that they can take that to market.
Absolutely. And that's the benefit of openness, right? Having that flexibility and that choice and that ability to have a more dynamic IT environment to support your applications and your services. You made a great point too about the sustainability. We find it's becoming certainly a huge consideration for any organization that has a real estate data center footprint, right? They're all looking at how they can reduce their energy consumption and provide more sustainability. And the other point you made, and it's a great handoff to Ihab, was about the better alignment between the compute and the network, right? In terms of compute resources and network resources, and how they can work more hand in glove. And in that respect, a big thing is having common tooling, right, across the network. And Ihab, I know that's something that's near and dear to your heart. So I imagine that's a big focus here as you look at how you're evolving to meet enterprise requirements.
Yeah, I will add to what Rebecca was saying about the open hardware. We'll definitely see lots of benefits from OCP and standard modular design. So more and more standard modular design is required, and goes with it some of the key tooling around security, BMC, being able to have a common model for the hardware, and lots of good activities by many of the people on this call in getting to some of those standard designs within OCP. For the software side, what I would say is, I think it's very clear now that open networking is not just open source. It's a combination of open source and non-open source. And it's becoming obvious that you almost need both in every single major new software product that you're going to put out there. So what Sonic did very effectively, it created standard protocols and management layer and SI interfaces to normalize for the different hardware options. And that needed to be open source because you need a massive community-based approach that is very successful at this time. But it also created enormous business opportunity for many, many companies to create software on top. So lots of services are now coming in, storage services, encryption, security, zoning, ability to do secure onboarding for zero trust for the edge, all that is deployed on top. And then the big area of opportunity that's not completely open source at this time is management layers and orchestration, fabrics, and AI ops, ability to automate your whole infrastructure. So that's kind of what is very obvious now, that you need a component of both, and they both orchestrate well from a disaggregated model. I still would say that we're halfway through on being able to make the hardware completely agnostic. I think you still have dependency on the features deep into the hardware, which is needed. You know, you really need those features in the hardware. But I think this is something the community will keep working on over time to enable more transparency of the feature and common outcomes, especially when it gets to new form factors like smart NICs, etc.
Absolutely, we're seeing efforts to provide abstractions, not just to decouple the network hardware from the network software, but within the hardware layers themselves and the software layers above the stack. There are efforts ongoing all the way through the stack, right? So I think it's a great point, Ihab. And Pere, that brings it back
Actually,
to you.
Can I build on that one a
Oh,
little
sure.
bit?
Sorry, Dave. Absolutely.
Yeah, no, I mean, this is an area that I am also really passionate about, because open networking is not about a race to the lowest common denominator. That's not going to support it. What it is about finding ways that lots of innovation can happen from lots of different organizations, but with coordinated communication and collaboration among those. So we're creating APIs not to force a common denominator, but to create languages by which the new novel capabilities of each layer of the stack can be expressed to the other layers of the stack. And there are a lot of technologies coming in here. P4 is being helpful. Pins is being helpful. Dash APIs I talked about is being helpful. And that's really what's exciting, is that we're opening this up to further innovation.
No, that's a great point. That's a great point, because that ties in with exactly what we were discussing, how the race for the right abstractions to really spur innovation that will contribute real value to customers is continuing, right? And it will continue well into the future. And Pere, I know as you think about the stack that VMware provides, right? You've got network virtualization for layer 2 and layer 3, network virtualization overlays. You also have load balancing. You have you know, ingress controllers and service mesh. You know all about how you have to provide the right abstractions for a software model, and I imagine that's a big part of meeting the evolving enterprise requirements as you're seeing more uptake of cloud native architectures in enterprises.
Yeah, I mean, there were some comments before from Dave and Rebecca, kind of like trying to tie with the notion of the service architect. Dave was mentioning that it's not about just how to connect things and move packets from point A to point B, but rather how do you add value to this service architect? And Rebecca was mentioning this notion of like distributed computing. So basically the realization is that in the past, we thought as networking as a passive component, like applications lives in the endpoints and then they need to be connected and packets flow through the network. But what happened is that application architectures have evolved a lot. And now what we have is like complex systems that interact with each other, right? So the network is not the network anymore. The network is almost like the application fabric at different layers. Now, because of that, you start thinking, well, do I just want to pass packets, or do I need to bring security and compliance as part of the solution? Do I want to meet kind of SLO monitoring capabilities? Do I understand if I have a bottleneck in the endpoints or in the network or in any place, how does it affect this interrelated distributed computing that Rebecca was talking about? And if you think the work that we do at VMware is almost like taking this top-down perspective, saying if the end goal is how to run applications in production environments with certain compliance, security, monitoring, and so on, and happens that those applications are running across multiple clouds, multiple locations, multiple clusters, and they run across multiple generations of compute. Like you may have mainframes, bare metals, Solaris workstations, you may have virtual machines, you may have containers, you may have serverless, you may have edge computing. So now it's like, how do you start thinking as networking, not as a way to just move packets, but a set of a software ecosystem of interfaces that they can be combined with the way service architects and application owners think, which is about CI/CD pipelines. How do I deploy in production? How do I monitor? Or DevSecOps, how do I run something and I keep running it with the proper security constraints? And how do you tie all the network components top down into this end-to-end solution? And this is the way we are trying to bring at VMware. The thinking is saying networking can be thought bottoms up or top down, and both of them are completely valid, and both of them require innovation and openness. But from a VMware point of view, we brought this top down because we want to start thinking in terms of application resiliency instead of thinking in terms of multipathing. or we want to think in terms of application SLO, in terms of packet loss. But in reality, both of them are exactly the same. It's just that you need to tie one with the other in a way that the business value becomes much more exposed and networking becomes way more relevant to the business owners and the value that the network brings into that solution.
Yeah, and it's a bit of a paradox because the value of the network as we move into this further into this cloud era becomes more important than ever, but the network is under pressure to become more invisible and less obtrusive than it's ever been. So
back to Dave's points about open source and value and ecosystems. I mean, if you think we're going to have many tools like open source, we are going to have ASICs, we are going to have many things, but the industry is going to a SaaSification of the services. Now, when you run it in a SaaS environment, the fact that it's open source or closed source or a hardware ASIC or something else, what happens is that what I care is about open interfaces. Because regardless if it's open source or not, I may not control it. Like if I have a Sonic running on a Microsoft Datacenter, I may not be able to control that as a user of Azure, but I can use the APIs that Azure may give you. So that's what I tie to my business value, my DevSecOps pipelines, and so on. So that's the aspect of creating a rich ecosystem of open components, open source, open standards, open interfaces. And then how do we attach through open interfaces to the consumption model of who is going to be the driver of networking and the whole solution compliance and so on.
Excellent. No, that sounds great. And with that, I think we'll move to the second discussion topic. And our second discussion topic, we're going to talk about the risks and rewards of open networking. And I know I talked a bit at the outset about the benefits, but I'd love to get the perspective from the panelists on what they see as the key benefits and the principal benefits to the organizations who are adopting open networking firsthand. And I think we can start with Rebecca this time. Rebecca, I wonder as the purview and the reach of the OCP innovations and what's coming out of OCP are spreading more broadly, where do you see the key benefits that your users are deriving from the technology?
Well, I think everybody has really alluded to this throughout the last full section. Any of these problems, what OCP really tries to do together is to source communities to solve the hardest problems that any company would find expensive, even prohibitively expensive to do on their own. And so it is when we can source the different hardware vendors all the way through to software innovation layers together that we can solve those problems. And even, again, open up new business models where, to Ihab's point earlier, it's open, but it's open with the kinds of support that end users are going to need. And every single community is different. You may have network architects in place to shape every aspect of traffic and do that. Or you may use an open cloud environment where you have APIs that allow you to SaaSify, as Pere was speaking about. So I think there's a lot that comes together within the community to do that work. And for us, that's the reward. It's that everyone is working together to solve these problems. And we're constantly learning as new community members come in, what we need to change, where we need to go forward together. And it's that combined sort of market synergy that allows us to solve these big problems, bring people to the table, and break down barriers so that we can have new aspects of innovation. So that's the reward. In terms of the risks, it comes down to, with openness in a very complex, heterogeneous environment, there's complexity, and you're going to need to solve that. So, I think when we look at hyperscale innovation, and a lot of OCP is driven by the initial innovations of hyperscale. We've talked a lot today about Sonic, and I think that's a perfect example of an area where a hyperscaler led an innovation path, and then we were able to sort of broaden it to a large set of end users through the open source community environment. But even in that domain space, there's constant innovation that's happening both in open source and in the different vendors and suppliers, in order to be able to ensure that those different end users can come together and continue to innovate. So the risk that I see always is that if there's not a path to product, if there's not a path to any kind of a user being able to trust and know whether their hardware design team is 5 people or 500, that is really going to be the challenge in an open source environment.
No, it's a great point. And I know, Dave, from your perspective at Microsoft, obviously you've got a bigger team, right? And you have a lot of resources, but you still face these challenges, right? I imagine it was a challenge from the outset. And as we see a democratization of some of the technologies that are coming from the OCP and more generally from open networking, I suppose other organizations, whether they be smaller cloud providers or large enterprises, are facing similar challenges. And I wonder if you could talk about, first of all, the benefits you've derived and some of the challenges you've overcome.
Okay, so I would say the benefits we've gotten have, again, with my Azure networking leader hat on, has been enabling more homogeneity across the management control planes inside of our network for a whole bunch of reasons, to manage supply chain risk so that we can adopt sort of the newest hardware technologies as soon as they're available. We have equipment from many, many vendors inside of our network, but yet I'm responsible for knitting that together into a seamless networking experience as seen by the services that run on top of that physical infrastructure. And so that's where open source and the APIs that'll decouple the different layers of the stack are so useful to us, and those are the benefits. And maybe I should say on top of that, now homogeneous layer, I get to make investments in that common network management system, that common network control plane system, and we can beat the bugs out of it. All software has bugs, but the more people using a piece of software, the longer the history we have using it, the more robust it tends to be. And so by concentrating the energy of all of my team on making that Sonic and Sonic enabled management control plane work at quality, there's a benefit to Microsoft and all of our customers. And similarly, as more customers adopt Sonic and use it in their scenarios, that code base gets stronger and all of the users of Sonic benefit. What are some of the risks that we saw? Things that people worry about is like, network engineers who have traditionally managed the network and operated the network won't be able to in this new world. Actually wasn't a problem that we found. Network engineers are learning to script, they're learning Python, they see as a way of ramping up their skill set and becoming even more relevant to more portions of the industry. So they're very willing to dive in and learn how to use Sonic, learn the level of automation. Are they writing massive distributed systems? Most of them, no. We actually have network engineers who have moved on to our software teams. They grow so interested in it, they build those capabilities and move on to our software teams. But there's enough commonality with the things we're already practicing that they were able to join together with our software engineering teams to build both the network architecture, all of the management control necessary to run that network, and then unify it with our services. So a lot of people worry about that. We actually have seen it a benefit. Our staff love it, and they like to engage on this. And honestly, because they could participate, it wasn't some hostile thing that they saw as a threat. It was this thing that they really wanted to engage with. If anything, I think the risk that we see from open networking is the potential risk of balkanization. So, we have efforts to get Sonic running on every network device in our network, from the smallest management switches in our data centers up through the largest wide area network routers. We're making great progress there. We're taking Sonic, we're running it on middle box appliances. There are people looking at running it on smart NICs and every place there is a network related entity in our deployments. But because it's so easy to innovate, it's so easy to take the source code and then start forking it for some particular use case, there's the risk of balkanizing, and that we could, instead of having a common platform that everyone's building on top of, that it gets sort of too specialized for each of these vertical application domains. And that's something where, from a Sonic project standpoint, we just keep trying to bring out all these communities, keep them talking together, so that the stuff that belongs in those common layers goes into the common base of Sonic, and it remains a platform that's then easy to innovate as needed. And that's something that I think we mitigate that risk of balkanization through continued community involvement and being open to all the different constituencies.
Yeah, that's that tension between openness and governance, right? Because as you sprawl into new use cases, and that's a good thing, right? Because it means the software is becoming popular, but it does present challenges in terms of, as you said, forking and some taking it along some paths that perhaps weren't anticipated at the outset. So absolutely. And Ihab, I know you've worked with Sonic, right? So you've taken this this innovation that came from some of the largest data centers in the world, providing networking there, and you've looked at how you can make this consumable and valuable in an enterprise perspective and the broader market. What you could talk about some of the benefits that have accrued and also some of the challenges in doing that.
Yeah, thanks a lot. So in terms of benefits, what we set out to do with open networking from the beginning was to solve, we would say, the use cases and really important challenges that cannot be solved today with networking. And for us, it's all about networking for storage and networking for compute. Standalone networking has always been, highly developed, but when it comes to being able to apply networking to compute and be able to spin up clusters and manage automation, et cetera, as well as storage, there has been a lot of limits there. So one of the key success stories we have with open networking is something we did jointly with VMware. We just launched NVMe over TCP/IP as a distributed open networking software while maintaining all the full discovery, automation, security, and being able to show that not only that improves TCO enormously for customers, but we've seen 3x performance for storage, everything from lower latency to improved IOPS to everything you can imagine, and even less CPU consumed for storage networking. We haven't seen a protocol deliver this much results for a long time in terms of storage, which shows you these are the gaps that have not been solved before. And it includes redoing the NVMe over TCP/IP stack in vSphere by VMware, included multiple product launches and a software tooling from Dell. But that shows you that that's the world we're going into. And I know we don't want to talk about telco or others, but you can imagine how that opens up to solving 5G and the fully disaggregated 5G ecosystem with results like this. The risks we see is, as you said, Brad, correctly, is that we've opened up the world now for a new persona, which is the developer who loves it. They want to go into the kernel, update it. They want to do everything they would like to do. And not all of these should be done from a management and support and scale. But what we cannot do is leave the infrastructure providers and these two network experts that have managed networks for years behind. So we've done a lot of development to provide the support for both. All the traditional management tools we built on top of Sonic, that's Dell Enterprise Sonic, plus we maintained all the openness and support for developers. And that's kind of what we have to do as a community, be able to support both, and in the future, open up the world for the data scientists and AI experts to be able to pull data out of it. If we don't do that in a horizontal way, we're going to risk building the old world all over again with vertically integrated platforms. But I think the community support that we have on Sonic and some of the other tools is so strong now that I feel very comfortable. This is more of a journey than a risk. So I do believe that the use cases are just exploding now with new form factors like the smart NICs. So computational storage, security, automation, all the edge use cases are now possible that weren't before. So I think this is a very good time in the industry. And it's clear to me how networking sits at the foundation of all of this.
No, it's a great point. And you made several great points there. And there's no question, you talked about NVMe over fabrics and, the innovations that are made on the TCP side. It really does allow, we talked about flexibility and choice. You can move toward a really a coherent network fabric that addresses converged needs, storage and general purpose networking in the data center. And then you talked about some of the things that's happening with data scientists, right? Where you're able to do more HPC on this network as well. certainly with SmartNICs playing a big part of that. So it's an exciting time. And Pere, I wonder if we could get your perspective on this, right? You're seeing, we had, of course, virtualization and network virtualization in the data center, and now there's the container and microservices challenge as well. So
Yep.
I wonder. Yeah.
I like Ihab's sentence that this is more of a journey than anything else, right? I mean, there's a sense of inevitability. And the way we approach it at VMware is, again, if you take the top-down approach, applications are already multi-cloud, like they are running in multiple clouds, multiple locations. It's a given, right? So the way we approach it at VMware is we say the network has 3 layers: the physical network, the virtual network, and the service network, kind of at the microservice level. And now each of these layers is innovating a lot by itself, right? Now, what happens is that at the physical network level, you're going to have innovations, for example, Sonic happening in a public cloud environment or in a private cloud environment, but you are going to have a heterogeneous system. You're going to have multiple types of networks that as they evolve, they get into a more open state with more open interfaces. So the layer on top can consume that. And now the network virtualization layer can provide certain controls in terms of how policies are managed or controlled in a coherent way across multiple environments, or how load balancers or firewalls are being perceived. And then on top of that, you have a service layer that now can essentially think in terms of how to route service entries, or how to monitor SLOs, or how to detect failures and switch through GSLB to a different location, and kind of create this dynamic aspect. The moment you think these 3 layers, now, if you think it overall, to Ihab's point, it's just a journey. It's inevitable that we are going to a more open, more dynamic, more self-managed state. Now, the problem is that as an industry, we still pick fights at the layer by layer. And now we say, well, I understand how my network runs today, and it feels risky to go to a different model. And well, that's a micro level point of view, but if you think it overall, you will get there eventually. But even if you look at the micro level, what happens is that, to Dave's point before, network engineers are asked to learn new things, because imagine that your line of business architecture has decided to go to the cloud. Are you still going to manage switches with a CLI? Like, no way, you cannot log into Dave's switches and with a CLI and change the config. It's impossible. So at this point, the network engineers, they have to learn new tricks, new techniques, because the meaning of networking is becoming way more broad. Now, once you learn that and you learn the kind of things that you can do managing the network in this way, then it's like, why wouldn't I do this in my own networks? And as soon as you taste the power and the value of this simplification, automation, openness, then it slowly permeates into other environments. And to Ihab's point, then it becomes a journey. Now, as any new technology, I would say the risk is using a tool that you don't understand how to use it, you can do a lot of damage. So a lot of times what happens is not that the new model is better or worse than the previous model, is that you don't understand the new model. And when you manage the new model, you mismanage it. And then you say, you see, it doesn't work. So it's almost like a cultural aspect that as we all learn these new tricks and we become more familiar with them, you get used to it. And I just want to use an analogy like we had many, many years ago, steam engines, and we had trains. And then we said, well, what if we switch to gasoline or diesel engines? They are easier to manage. Oh, but gasoline explodes. We are all going to die in our cars. Like, guess what? We managed to put like gas tanks that they don't explode. Now we say, oh, we are going to have electric engines. Oh, lithium batteries explode. We are all going to die in our cars. And it doesn't happen because we learn how to manage and contain the batteries and keep them cool. So any new technology has its own challenges, but as an industry, we learn how to manage those challenges and we benefit out of the improvement that the new technology gives us. So this is exactly the same. It's not that if you mismanage an open network, you can damage the network, of course, but you can mismanage an existing network and damage the network too. So it's just a journey on how to master the new techniques and get the benefits of the new open models.
Yeah, it's a great point. There's obviously the technological innovation is happening, and then that overcomes any sort of distrust that operators have of the new, right? They become familiar with it and they realize it can do the job. I know we have to move on to our final segment now, and that is questions that we're going to ask around the future. So now let's talk about the future, right? We know that a lot of progress has been made, and we've covered that in today's conversation. And I think we've sort of touched on where it's going from here. How is it changing, what it means? I think Pere kind of touched on it. The nature of networking. It's going right up to the services and directly contributing to the digital experiences that users are having. Rebecca, I wonder from an OCP perspective, if you could touch on these points, the future. I know you have a very aggressive roadmap at OCP, so I think that's a great lead in.
Certainly. When I think about sort of this overall journey that we're on within open networking, we've already talked about disaggregation. We've already talked about sort of managing at scale, whether it's distributed computing or even just telemetry and visibility. There was some references to pins earlier, and I think there's so much that is going to happen with that network shaping and traffic management out and through to security as architects embrace more this evolve or die approach that Pere was talking about earlier. I already talked about sustainability, and I think we will continue to innovate in this domain as well with a different mindset of, maybe not the best and fastest every single time, but the most durable and longest lasting and most reliable, which is a different mindset for technology innovators to look at and think through, and it will be hard. And I think the other area we've really talked about a lot today is integrated solutions. That it's great to have open, but if you cannot pull it all together with some sort of a support model, with some sort of manageability, whether, we've talked about everything from vSphere and Kanzu, and in this domain, there's many areas where we're going to need more integration and solutions and management all the way through to ensure that we can actually take advantage of this new and innovative technology space. So all of that will continue and keep evolving as we go from the cloud to the edge, as we continue to have different diversities of workloads. I also personally, I get excited when I think about even the next layer of innovation on the system side. So optics and greater optical convergence. There's a huge amount there. Ihab was speaking earlier, I think, about the smart NIC revolution or IPU revolution. Huge amount of innovation that's going to happen in that domain space. But even further to the composable silicon concepts, right? As we see more innovation in chiplets, now you've got almost a fabric within the SoC. There's always been fabrics within SoCs, but now we're going to move even more to potentially thinking of that as its own mini network all the way out to the edge. And how much can we continue to expand and innovate in that domain space? And then again, these workloads, the methodologies that we're going to approach for cooling. We've got cold plates, certainly that's been around for a while, but immersive cooling. Now, as we think about edge and scaling up to massive data centers, but also down to very power constrained environments where the thermal, limitations make us look at innovative solutions that don't necessarily operate exactly the same way as air, obviously. So we have so much to do within systems innovation to support the evolution of diverse workloads moving out to the edge. Lots to happen. It all has to come together somehow, and we all have to be able to support end users in creating these, transformative experiences. So I think we have a lot to do. This is just about pulling data to where computation needs to happen. And in that journey, we need to innovate together.
Yeah, absolutely. And you made a great point, right? It's a very bright future, but the challenges are clear, and some of them are, big challenges, but there's a plan and you're moving through it. And Dave, I wonder if you could elaborate on that from your perspective. I know you talked about the kind of next stage where you see all of this going.
Sure. I think that open networking it's an unbridled force, at least in the industry, and we're just going to see more and more of that. As I mentioned, we're going to see it at every different layer of the network. Rebecca and Ihab brought up the optics space. Again, that's another domain where this kind of openness, I know inside of Microsoft has given our network engineers more visibility to what's happening at the physical layer, so they can design and optimize better network transports, and they can, again, tie those transports into the service layers running on top of them. that type of composition is a really amazing area for future innovation. I think that the legacy of open networking is going to be this kind of innovation happening in all different domains. When we let creative people with hard problems get into the various components, start to mix and match them, add their own code, their own secret sauce where necessary, we see really creative solutions at all the different layers of the stack. And as we see, like to Ihab's point about storage transport changing, we see where SDN is implemented in the network changing. We're going to have to give the industry the flexibility to provide packet transformations, packet monitoring and logging capabilities at every different part of the packet's path from one application to another under the control of that service architecture. And that's where open networking is going. And so we'll see it across all types of devices, across the entire network, from the data center to the edge, to the enterprise environment, to customers' homes. And it's going to be amazing to see what happens.
Thanks very much, Dave. It's a great point, right? It really is the entire stack, and it's all places in the network, and it's continuing to move forward. And Pere, I wonder if you could give your perspective from VMware. I mean, you already talked about those three layers, right? Physical, virtual, service. It's a big part, I guess, of innovation is going to continue on all three fronts.
Yeah, so from my point of view, I mean, the future of open networking is what we started at the beginning, right? Is how do we bring networking at the fundamental business value, and essentially how do we bring the automation, the compliance, the security end-to-end across the three layers. And as we go down the stack and the discussions we are having about Sonic and the extensibility of P4 and composable systems and the NVMe over fabrics and all those things that we've been mentioning, is this aspect that the physical network had been for many years close to that innovation that I'm talking about, kind of like the extensibility aspect. And suddenly, by the fact that now we can program silicon, we can have operating systems for switches that are extensible and open, that the fact that we have SDKs with P4s and extensibility languages and eBPF that now you can use to extend the protocol formats and the transports that now you can innovate in storage rather than just in IP networking. All those things, essentially what they have unlocked is that now even the physical network is a fundamental component of this application fabric that we are discussing. And that's the innovation that open networking is bringing to the industry.
I think that's great, and that's an important point. And then Ihab, and then I think we'll have a chance for all of you to kind of leave the audience with a final thought. But Ihab, I want to give you an opportunity here, and then we'll move to the summit.
Yeah. No problem. I think most of the topics were captured by everybody. I think we're all in absolute alignment here. So what we see is 3 areas of future of open networking here. One is storage. Networking is just the beginning of data management, data distribution, the explosion of data. Data mobility is all now enabled. Second one is accelerated compute, AI. Most of it really needs network fabric with very low latency, highly distributed, programmable, so that marrying between CPU and networking is happening at an amazing way now. And third one is IPUs. Rebecca talked about it. I think IPUs is the biggest single architectural change in data centers, and it's all about networking and ability to program it.
Absolutely. No, I think that's great. And now I think we're at the point of the presentation where everybody can leave the audience with a final parting thought. What you feel is most salient about the topic of open networking and where it's going. And I think we'll start off with Pere. Pere, if you could provide a final thought, a kind of summary of what you want to leave the audience with.
Yeah, we'll leave it quick since we are running out of time, but essentially that this open networking mindset and movement has forced, if you think, a big transition in the industry, where before we were almost like restrained by the network, like we couldn't deploy applications fast enough or open firewall ports fast enough or do migrations fast enough because we had networking dependencies, and that was out of the application value. Fast forward a few years, and now we have DevOps, DevSecOps, GitOps, all these things that are driving automation innovation at a space that we've never seen before. And this is because we found ways to incorporate the network into those solutions. And that led that all the layers of the network that we were discussing, the service network, the network virtualization, the physical network, had an explosion of innovation to catch up with those requirements. And if you think, just to close with this, is open networking has helped transform the industry from an agility, from a security, from the way we develop applications that would have not been possible with this type of innovation at every single layer of the stack from an open networking point of view.
Excellent. Ihab?
I think the phenomena is really simple. I think everybody knows the world has moved to DevOps, cloud architecture, cloud operating model. If you move to cloud, it's not possible long-term to keep two independent control planes, one for an independent network, one for your compute. And therefore, open networking and tools like Sonic are probably inevitable in the long term. What we are all doing as a community, and we are at Dell, is to try to continue to support all the key network architects in the mission while enabling the developers to bring the two together. I think this is going to happen for all services, for all segments. It's just a matter of time.
Excellent. Thank you, Ihab. And Dave, I wonder if we could get your summary here.
Sure. If I think back a few years ago, as I was on the stage at OCP presenting Sonic for the community for the first time, and there was a palpable question in the air, which is this going to be real? Is this going to work? Is anyone going to actually trust this kind of software to run their networks and to run their businesses? And I think now the answer to that question has been answered. The answer is yes. There are over 30 major enterprises on the public record as using Sonic as a key part of their network infrastructure, and there are many, many more that are using it. The Sonic community has over 1,600 active code contributors. It's a vibrant ecosystem with many vendors as well as users. We're seeing support models come up. And Microsoft, I can say from my own day job again, has really seen the benefit of the innovation, the creativity, the quality that comes from engaging in this open networking ecosystem.
Thanks very much, Dave. And Rebecca, I wonder if we can.
I'm going to just double down on Dave's statement. The possibilities within any open domain are endless. There's so much that we can do together as a community, but you have to show up. You have to show up, you have to contribute, you have to be part of the 1,600. You got to make sure that your needs are heard. And you can do that any old way. There's ONF and many, many different open communities within this domain space, Linux Foundation themselves. But I really want to, make a call out for OCP in the sense that this is a community that is very active in bringing together hyperscale innovation, vendors, any end user and community. There's no fees to participate in the open projects and learn and grow and tell us what we're missing so that we can continue to be better together.
Excellent. That's a great high note to end this the day's proceedings. I just want to thank all of the panelists today for their participation and involvement in today's session. It was a lively discussion and I think a highly informative one as well. So thank you, Ihab, Dave, Rebecca, and of course Pere. I welcome your participation today, and I think we had a great discussion for the media audience.